When a multi-agent system fails, the final answer is usually the last symptom, not the first cause. The real bug may be a bad route, a missing handoff field, stale state, or two agents bouncing the same task forever. So the first debugging rule is simple. Debug the boundary. Do not start by reading every prompt. Start with the trace of who acted, what they sent, what state version they used, and who owned the next step. A useful trace event is structured. Step number, agent, action, target, state version, and a short message. That is enough to reconstruct the workflow without logging private reasoning. You can see that the coordinator handed off to billing at state version 1. Then billing handed back to the coordinator at version 2. Then something used version 1 again. This kind of trace lets you debug behavior without turning logs into a transcript dump. The first detector looks for repeated handoffs. If the coordinator sends work to billing 3 times, the system is not collaborating. It is looping. A loop limit is not only a safety feature, it is a debugging signal. The moment a pair crosses the limit, you can inspect the exact boundary. What did the coordinator send? What did billing return? And why did the coordinator think retrying was useful? That is much faster than staring at the final answer and guessing. The second detector watches state versions. If a later step uses an older state version, you may have a stale read, a retry bug, or a bad branch merge. This is why state versions belong in traces. Without them, stale context looks like bad model judgment. With them, you can say, the answer was wrong because step 4 used state version 1 after the workflow had already moved to version 2. That is a fixable engineering problem. The third detector checks for final ownership. A workflow can contain useful specialist work and still be incomplete. If no event says final answer, nobody owned the final response. This is common when teams add specialists but do not define who synthesizes the answer. The agents all did something, but the workflow never closed. A final answer event makes ownership explicit. It also gives tests a clean completion condition. A good debug packet lets someone investigate the failure without rerunning everything. It should include the run ID, task ID, sanitized input summary, trace events, state versions, tool calls, and final output if one exists. It should also include what changed. New prompt version, new routing rule, new tool schema, new model, or new state reducer. Many multi-agent bugs are introduced by a small behavior change at one boundary. Do not put secrets or private reasoning in the packet. Redact sensitive payloads and keep enough structure to debug the decision path. The packet should answer one question. Where did the workflow first become wrong? Use this as the interview answer. I debug multi-agent systems by tracing boundaries first. Route decisions, handoffs, state versions, tool calls, and final ownership. Then I run simple detectors for repeated handoffs, stale state, and missing final answers. I keep logs structured and sanitized so I can reconstruct the workflow without exposing private reasoning or sensitive payloads. Debug routing and state before blaming the model. Most multi-agent failures become clearer once the boundary trace is visible.